Good morning, everybody. Welcome to Wednesday's video. In this one, we're just going to factor some more. At this point, we know every method we need to know for factoring, and we're just going to practice a bit more, look at some unique scenarios, and work on that. So today, I really want us to practice decomp a little bit more. We'll start with a recap of that. The majority of the homework is just going to be on good old-fashioned decomp, and then we'll just look at some other examples just to see where it could go. So with that said, let's jump right in. Alrighty, so we're jumping right in. We're going to do some factoring review, and we're going to do review decomp, which is what we learned yesterday. So decomp was when I have a value that's not 1, or I actually have a coefficient on the x squared. So I can't use inspection. I've already looked for the GCF. I've already done all of that. And now I have to use decomp. And so what we do is we still look for a magic combo, where I'm going to multiply to one number, add to the other. But the multiply comes from the a value and the constant. So 6 times 2, 12. I have to multiply to 12. And then I'm going to add to the middle, same as I always add to 7. And what we mean by decomp is I'm actually looking to break apart this 7x. I'm looking to say, hey, can I decompose this into 2 pieces so it still adds to 7x, but maybe I can factor by grouping and I can do something different. So those numbers would be 3 and 4. Positive 3 and positive 4, which allows me to rewrite. I need the equal sign, that's important. 6x squared plus 3x plus 4x. Or if you said plus 4x plus 3x, we get the same thing. We would just do it in a different order, but it's all good. Okay, great. Well, now that I've done this, what I can say is factor by grouping. So I'm going to factor out a common factor from the first 2 terms and a common factor from the second 2. All right, well, the first group, 6x squared plus 3x, I could factor to 3x. I'd be left with 6 divided by 3 is 2, x squared divided by x is x, plus 3x divided by 3x is just 1, so 2x plus 1. Okay, next group, 4x plus 2, I could factor out a positive 2, so plus 2, the plus sign is really important. Then you're left with a 2x plus 1. Hey, that's fantastic because I ended up with a 2x plus 1 and a 2x plus 1. I have the same bracket in both terms, meaning I can factor out this bracket. Both terms have a 2x plus 1, so I'll factor it out. I get 2x plus 1. And then what I'd have left is, well, I got rid of the 2x plus 1. I have 3x. Got rid of the 2x plus 1 plus 2. 3x plus 2. And there you go. We factored by decomp. So that's the method we can use for a large majority of things. It works a lot of the time. And it's really, really important to have. So we're going to practice that a lot today. Okay, let's do one more. 4x squared minus 13x plus 3. I look for the common factor. I don't have one. I have this a value of 4, meaning I can't just do inspection. I have to go multiply to something, add to something. So I would multiply to, 12 again. 4 times 3 is 12. Add to negative 13. Looking for that magic combo. Well, I'm adding to the negative, but I multiply to a positive. So I know my signs have to be the same. They're either both negative or both positive. And since I'm adding to a negative, I know they're negative. And you think, well, what multiplies to 12? Maybe negative 3 and 4. No. Negative 2 and 6. No. Oh, negative 1 times negative 12. Those would add to negative 13, multiply to positive 12. So there you go. There's my decomp. I can decompose. Instead of saying minus 13x, I'm going to say minus 1x minus 12x plus 3. I blew it up. I decomposed it. I broke it apart. Now I factor by grouping. First 2, second 2. And the second 2 is going to be maybe a little trickier, but that's okay. Within the first one, it looks like I have an x as my common factor. And I get left with a bracket of 4x minus 1. And in the next one, minus 12x plus 3. If my first term in the group is a negative, I have to factor that negative out. So between 12 and 3, I have a GCF of 3. But I'm also going to divide by negative to bring that subtraction out front. You get 4x minus 1, which is great because it gives me the common bracket and the common bracket, and I'll factor that out to get my final answer. I'd be left with an x and a minus 3. Fantastic. There you go. So maybe a trickier example, but there you go. That's decomp. So today what we're going to do is look at some specific scenarios, some specific ideas, but ultimately just practicing decomp more and more so that we're solid with this method. So let's jump to your workbook now. This is page 365. And we're just going to look at some weird scenarios. Okay. So the first one is there's something called the perfect square trinomial. And if I'm thinking, well, a perfect square, that's like something times itself. Like I know 16 is a perfect square because that's 4 squared, or 4 times itself. Or 81 is just 9 times 9, 9 times itself, or 9 squared. Well, I can have a trinomial that's a perfect square if it's the result of something squared. Okay, so if I look at p plus q squared and I multiply that out, okay, and I'm going to open up and do that somewhere else so that I have some space. P plus q squared, that would equal, well, I know that that's actually a binomial times a binomial because it's p plus q times itself. And then we remember that I do FOIL. This goes back to the kind of the first half of the unit. So I'd get p times p is p squared plus p times q plus another p times q and plus q squared. So if I combine in the middle, I have 2 of those pq terms, or 2 of the middle term. And I think we kind of looked at this when we multiplied out. The other one was p minus q squared. And I'll do this in a really similar way. That would be p minus q times itself. So binomial times a binomial. This is where I'd have to do FOIL, or repeated distribution. P squared minus a pq this time, minus another pq, and minus q squared. And there we go, 2pq minus q squared. So those are my multiplications. And what we're going to look at, we'll jump back to our workbook, and we'll talk about where those come from. Okay, p squared plus 2pq plus q squared. And then the other one was p squared minus 2pq plus q squared. Okay, so what we're looking at is some patterns or some ideas that I could pull from with a perfect square trinomial. And what I notice is the first term, p squared, is always just, well, whatever my first piece is squared. Okay, p squared. And the last term is whatever my last term in the initial binomial was squared. And in the middle, I always have the same piece twice. It's the product of whatever my first and last term were twice. And if it was a positive, it's plus. If it was a minus, it's minus. So I could say the first term is the square of the first term in the trinomial, or in the binomial. The last term is the square of the last term, okay, or second term. And the middle one, okay, is, well, it's 2 times, it's twice, or it's double the product of those 2 terms. I had, maybe I'll go back to here. I had the PQ one time, and then I had the PQ a second time. PQ once, PQ twice. So it's double the product. It's not a very nice T. The product of the first and last terms. Okay? And that's really important. And I don't know if we 100% need to recognize this. Okay, but it's neat to notice the patterns. And you're going to go to more of this actually in 20. But more so, I'll kind of talk about how we can notice these things or what it actually means. So it says in a perfect square trinomial, the first and last terms must be perfect squares. Yeah, absolutely. X squared and 25. And then the middle term must be twice the product of the square roots of the first and last term. So x times 5 would be 5x. Twice that is 10x. That's where the middle term comes from. And that's kind of the pattern we looked at here. But again, not super important to know those little details. It's more so just important to recognize when you have a perfect square trinomial. So we go to these questions. It says, which of the following are perfect square trinomials? Well, what I would tell you is factor them. And if both of your factors are the same, it was a perfect square. It was something times itself. But if you factor it and they're not the same, you know it's not a perfect square. So like a squared plus 4a plus 4. I'm looking to factor by inspection here. Okay, multiply to 4, add to 4. Oh, that would just be 2 and 2. So my factors are a plus 2 times a plus 2. And then here's where we now recognize the perfect square trinomial. Hey, that's just a plus 2 times itself, or a plus 2 squared. So fully factoring that thing would actually be to write it as just one bracket squared. So yes, that is a perfect square trinomial. Okay, x squared minus 9x plus 6. I could multiply to 6, add to negative 9. Well, those numbers would be, can I even do that? Can I even do that? Well, no. That's not even possible. That's not even something that I could factor. Okay, there's no product that multiplies to 6 but adds to negative 9. So that is not factorable. So it's certainly not a perfect square trinomial. And that's all we're going to do. Okay, so if I ever ask you if something is a perfect square trinomial, factor it and see if you get the same two factors, and that's all we need to do. Okay, next question. This is a little interesting, and I don't think I'd ever ask you to do this, but it's interesting to consider. Fill in the blank so that each of the following is a perfect square trinomial. So what I need to remember is this middle term. I have x squared and 100. This middle term has to be double whatever the first and last term were initially. So I'd say the square root of x squared is x. The square root of 100 is 10. So I had 10x. But then I had double that. So 20x, and I can fill that in. Okay, and that's from the pattern we looked at above. If it was a subtract, yeah, it could be minus 20x, same situation. Okay, C is maybe a little bit more complicated. C is a bit more complicated. The square root of 25x squared is 5x. The square root of 36 is 6. So 6 times 5x would be 30x. Okay, and then I needed double that. So 60x is what I would fill in the middle. So I'm not super worried about that. I just wanted to show you we can kind of think our way through those, but that's not something I'm actually going to ask you to do. Okay, so let's move on. Okay, this is I think a little page ahead, and it's at the bottom. I'm skipping the main blurb. I want to go back to decomp now. Okay, and here's an interesting scenario where decomp is going to work for a large portion of things. A to the 4 minus 5a squared minus 14. Well, everything I've factored has just been a power of 2. It's been a squared or x squared or y squared or whatever. This is a higher power. Well, what I want to show you is decomp works for a majority of things. So if you have something you don't know how to factor, try decomp. Okay, I've got a coefficient of 1, constant of negative 14, so I'm going to multiply to negative 14. And I'm going to add to the middle, which is negative 5. And I'm going to keep the terms the same way. I'm just going to decompose that middle term. So that would be multiply to negative 14, add to negative 5. That would be negative 7 times positive 2. So as I decompose a to the 4, and then I'm splitting up the a squared, it's going to be minus 7a squared plus 2a squared. Just busting apart that middle term, minus 14. Great. Okay, I can absolutely do that. Well, now I could do grouping. Group the first two, group the second two. Let's see what we get. And this is where it's a little different because I can factor out something bigger. I can actually factor out an a squared. And inside I get left with an a squared minus 7. And in the other group, I could factor out a positive 2. So plus 2 a squared minus 7. And hey, it worked. It's a little different than my normal decomp, but I have the same factor, a squared minus 7. and I'd be left with an a squared plus 2. So decomp is a method that can work for a variety of things. So we can try decomp when we don't know how to factor something. It works for such a variety. Okay, I don't want you to do C, but I want you to try B ahead of me. So pause, and then I'll give you the answer to that one.
A little longer than a few minutes later.
And there you have it. There's our answer for B. You can see my work, and hopefully you got the same answer. This one is not actually, it says factor completely. It's not actually done, but I'm going to come back to it when we look at something a little differently at the end of this lesson. We'll come back to this question and specifically this part. So just keep in mind that we're going to flip back. Okay. Let's go on again. I think this is maybe a page ahead. Number 5. Well, I can do decomp when there's a bigger coefficient as well. So 4x to the 4 minus 5x squared minus 6. 4 times negative 6, I need to multiply to negative 24. I need to add to the middle negative 5. So I can do decomp even with this bigger thing. Okay. Well, that would be, I think I have a negative 8 and a positive 3. And now I can break this apart. 4x to the 4 minus 8x squared plus 3x squared. So it's still minus 5x squared. It's still that middle term. I just broke it up. And then minus 6. Okay. Factor by grouping. I'll put my two groups together. I can bring out a 4x squared. And I get left with x squared minus 2. And then I can factor out a positive 3. And I get left with x squared minus 2. And hey, my decomp worked again. X squared minus 2, x squared minus 2. So I can bring out that common factor. And then I have my 4x squared plus 3. Okay. We're not going to do B and C. I just really want to throw this out as decomp is a really great method. So it can do a variety of things. The more confident we are in decomp, the better. We're normally going to look at things like I started class with, the decomp we did yesterday. But decomp works for a lot of things. So whenever you have a kind of a doubt, you can try decomp. Okay. And let's go on. This is the last thing. So again, I think it's kind of a page ahead. Maybe more than a page ahead. Kind of the last thing we're going to look at is we're going to go back to difference of squares. Okay, so it says factor these completely, and I really want to emphasize that word completely, which means if there is a method of factoring that I can still do, I need to do it. Okay, and this is always, I always factor at a GCF, and then if I can do inspection, I do inspection. Or if I can do difference of squares, I do inspection. I always do the method all the way till there are no more things I could factor. Well, k to the 4 minus 1 is a difference of squares. And remembering a squared minus b squared, I get a minus b times a plus b. Okay, so k to the 4 is just k squared squared. And 1 is a great number because it's just 1 squared. 1 is fantastic. So I can actually factor this to, I have a squared minus b squared. So a minus b times a plus b. Hey, that's awesome. And maybe if we looked at that, we'd say you're done because I've done the difference of squares. But what I want us to notice is if I look at my two factors, k squared minus 1, that is a difference of squares. You have k squared and you have 1 squared, right? 1 is that great number. So I can actually factor that further. K squared plus 1, I might be tempted to factor, but then I remember it's a difference of squares, not a sum of squares. So this one is done, but I can actually still factor k squared minus 1. That would factor to k minus 1, k plus 1. And then I still have the k squared plus 1. So factoring completely means, hey, if there's any of your factors that you can still actually keep going with, keep going. Absolutely keep going. And we're going to find that we can factor even further and further and further. Okay. So let's actually jump back to 2 questions ago when I said, hey, this thing is not actually factored all the way. Okay, this was x to the 4 plus 4 squared minus 5. I have my 2 factors, but hey, x squared minus 1, I can actually factor that Further, that's a difference of squares, x minus 1, x plus 1. I just factored this section, and the other factor is already done. So it can stay the same. So that is actually my final answer. If I said to factor completely, I need to always work my way down. No matter what method, if I get something that can still be factored, I factor it out using one of my methods. Okay, let's jump back. Okay, B, 80 minus 5x to the 4. Well, I look at that thing and I have no clue. Okay, I look at that thing and I don't really have any idea. But maybe I think, hey, the first method I always look at is GCF. And that thing has a GCF of 5. You could factor out a 5. Okay, and you'd be left with minus x to the 4, 80 divided by 5 is, oh my goodness, why can't I not do this? 80 divided by 5 is 16. Okay, pull my calculator for that one. And then I look at what I have in the middle. Hey, that's a difference of squares. That's 4 squared and x squared squared. So I could say it's 4 minus x squared, 4 plus x squared. A difference of squares. And then you keep going because you say, hey, if there's something I can factor, I keep factoring. And this one is another difference of squares. 4 is a perfect square, and x squared is a perfect square. I get 2 minus x, 2 plus x. And then I still have the 4 plus x squared, and I still have my 5 out front. And now it's fully factored. So always, always, always. Most of the time I factor once and I'm done, or I factor out a GCF and I factor, but hey, sometimes I'm going to have different things to look at, and I can factor further and further. Okay, go ahead and try C ahead of me, and my advice would be pull out a common factor first, and then hopefully you're left with something good. So go ahead and try that one ahead of me.
A few moments later.
And there you go. I did that one ahead of you. Check your answer. Definitely a harder question. Working with 3 variables there, but if I follow the same ideas, it's actually all there. So probably more complicated than anything I'd give you, but worth a shot and worth factoring all the way. So that is actually it for today. So really, this is kind of a thrown together lesson of just kind of, random things that we can factor. And I just blend all my methods together. I'm confident in all the methods, and I can factor basically anything that gets thrown at me at this point. So we're going to go to some homework. Okay. Page 358. That's actually yesterday's homework. Yesterday you did 3 odd and 4 odd. Today you're going to do the even ones. So that's decomp. And I really want you to be solid in just kind of the basic decomp questions. And then page 369, 4A, 5A, 6A. I just want you to look at some of the random ones that we looked at today of kind of factoring completely or maybe using decomp in a different method. So that's the homework for today. And then you'll also have a check for understanding assignment on quizzes that you can do as well. So as always, send me, a question in the form, all of that, and make sure you give it a really solid attempt. But then reach out if you're having any difficulties. So there you go. And that is it for today's video. That is a good use of decomp and looking at some other methods. So at this point, we're actually done factoring. We learned the GCF, we learned how to do inspection, we learned difference of squares, and now we learned decomp. And with those 4 methods, we can factor everything that I'm going to throw at you. So today we're going to focus, we're really going to work on our decomp and get that down. You have a short little check for understanding on quizzes, and you can do that one. To work on your decomp, that one I'm actually giving you 3 attempts. So if you get a question wrong, you can go back and try it again, and I'll record your final attempt. And then if you look at tomorrow, we're going to review factoring as an entire thing, and then we'll have our weekly assignment on factoring on Friday. And then even looking to next week, Monday, we're going to do a final review where we put everything together, the add, subtract, multiply kind of factoring, and then the factoring, putting all the pieces together, everything with polynomials. And Tuesday will be our first summative assessment, which is like a unit exam, but it'll be an assignment, right? It'll be on Google Forms, a little bit longer than our weekly ones, and that'll be on Tuesday. And then after that, we can move on to a new unit. So for today, do the homework, do the quizzes, ask lots of questions, all of that stuff, and I will check in with you guys again tomorrow. Whoa, that was a close one. I almost forgot. Say smash that like button, hit subscribe, all of that, and tune in again for the next video. Now we're done.